How you guys doing? You doing good? This is Ben and I love math, and welcome to Ben Loves Math. This is the first lesson of our last unit. Unit 11 is all about statistics. Day 1 is going to be talking about scatter plots, which are things that look like this. It's plots of points that are kind of scattered around. We're going to be able to match scatter plots to equations of lines, and we're going to be able to find lines of best fit, and figure out what that is, and be able to find them using our calculators. Alright, so vocabulary, scatter plot. That's one of these things. We've also got some more examples here. So if you just look through your notes, these little graphs of all these dots scattered around, that's what a scatter plot is. And it represents real world data. Regression, actually let's go to here, line of best fit. Line of best fit is a line that kind of shows the pattern of the data. And a regression is the math that's used to be able to find this line. We are going to use our trusty calculators. There's a way to do it by hand, but that's kind of beyond what we need to do for Algebra 1. It takes several sheets of paper to do one line. So we're going to skip that and just use our calculators as a tool so that we can do some more interesting things with it. So scatter plot is the graph, line of best fit is the line that goes best matches this, and then regression is the math that is used to find that line of best fit. So what can we tell from the graph below? Take a second, pause the video, come up with one or two things that you notice about this graph that you could explain to me about the meaning of this graph. Pause it and come on back. Welcome back. All right. So did you say something like, well, it increases the later the year, the higher the minimum wage is. It does change. Sometimes it stays the same though, like it hasn't changed at all since 2008, I think it is, 2009. But you can see that we kind of have a pattern that it's going up over time. Right? That's the main thing we're looking for there. All right. These three graphs have something that's called correlation. One of them is positive correlation, one of them is negative correlation, and one of them has no correlation, none. Take a second and predict. Do you think this one's positive, negative, or none? Do the same thing with this one and do the same thing with this one. Circle your answers. Did you say that this one was positive? All right, kind of looks like if we were to draw a line, it would have a positive slope. Slope dude would be puff, puff, positive. This one, I can't really tell. I wouldn't be able to predict anything. Like here, if x is equal to 9, I could predict that y might equal 7, somewhere around 7. That's an estimate. It's not an exact answer, it's an estimate. Here, 9, I don't know. It could be here or here or here or here. There's not really a pattern here, so I can't find out. Y is equal to, I don't know. That's no correlation. Correlation right here to relate. Relation. And this last one, again, if we were to draw a line through it, that's a negative slope, nice, negative. And let's see, that would be, I don't know, around 1.5, I guess. Somewhere between 1 and 2. Again, it's just an estimate. So, positive relation, negative relation, no relation. Moving forward. All right, you have two choices here. Is it linear or quadratic? Is this linear or quadratic? Is this linear or quadratic? Is this linear or quadratic? Take a second, pause the video, circle one of these answers for each of these. If you can, go through and also match an equation to each line or curve. Come on back when you're done. Welcome back. All right. This one, if we kind of drew the pattern, it makes a line. That would be linear. This one makes a curve, like a parabola, like our quadratic, our x squareds. Linear is just x, quadratic's x squared. Again, a line. That's going to be linear. Oh, man. And a parabola, again, is going to be quadratic. Now, between these two linear equations, see these are x, and this one's x squared, and this one's x squared. Between our two linear ones, which one matches which? 2x. Well, that's a positive slope. Positive slope, so it must be that one. Or we could also look at the intercept. The intercept of 1 is around here. This intercept is around 10. That's here. So intercept of 10 with a negative slope. This is going to be B. All right? C, we can't really look at the intercepts here, but if you remember, if A is positive, that's a smiley face. Positive is good. So that's C. C is positive. If it's negative, that's a frowny face. A little tear. That's going to be D. So keep that in mind. All right. Your chance to do some examples. Pause it. You're just going to write down here linear or quadratic. And come on back when you're done. Welcome back. All right. Linear, linear, quadratic, quadratic. Easy peasy. Moving on. How are scatter plots with positive, negative, and no correlation similar? How can you tell if a scatter plot has positive, negative, or no correlation? And what is the difference between linear and quadratic? Pause it. Put some thought into these. Take a couple minutes, write in complete sentences. Don't just write a couple words down. Answer these thoroughly. Put some thought in. And when you're done, come on back and I'll give my thoughts. Welcome back. All right. I am just going to put a couple words because there are so many different things here. How are they similar? Well, they're all scatter plots. All scatter plots. They all represent data. I don't know. I'm sure there's other similar things that you can think of, and I look forward to reading your notes about this, but that's the main idea here. How can you tell if it's positive, negative, or none? You could have drawn a picture here, I guess. Positive, negative, none. All right? Something like that. Now, what's the difference between linear? Linear makes a line. Not necessarily a perfect line, right? If we go back to these, it's not a perfect line, it's scattered, but the pattern is linear. Quadratic makes a parabola. Something like that. Look forward to seeing what you guys have written for this. All right, how are we going to use our calculator to find a line of best fit? Lots of things to do here. We're going to be using our calculators to do this, and there are lots of different parts. If you look at the very last page of your note packet, there are some tricks about how to clear memory and how to look at your plots and stuff. You're going to need to be able to do this, and we can't tell you how to do this on the SOL, so it's very important that you learn how to do this on your own and be able to remember how to do that. So let's start. We're going to go to Stat, Enter. On Stat is right here. Enter for Edit, because we're going to edit our list. There's already numbers in here, so I want to erase this. I'm going to highlight the name of my list. I'm going to hit Clear. Nothing happened, but when we hit the down button, it goes away. So now you try it for the other list if you have data in there. Highlight the name, hit Clear, hit down, and it's gone. And now we're going to enter these numbers in, and it should look like this at the end. So I'm going to go enter these numbers in. 9, 13, 21, 30, 31, 31, 34, and 26, 32, 42, 53, 56, 55, and 59. All right, so it should look like that. Looks good. Next, we're going to find the linear regression. Before we do that, actually, let's look at our graph. I don't see anything. Again, this is on the last page. If you want to zoom in on your dots, you're going to go to Zoom, and if you scroll down to 9, oops, try that again. Scroll down to 9, Zoom Stat. We're doing statistics. And look at this. It's thinking. I think I might have messed it up. Let's try this again. Zoom 9. What's wrong? Oh, that's right. We need to turn plot 1 on. We don't want these things here. This has nothing to do with our scatter plot, so let's clear those out. To see your scatter plot, you have to turn plot 1 on. You need to highlight it, hit enter. See, it's highlighted now. Now we can see them. What is going on here? Stat. I've got one too many numbers in here. I need to delete that. So when it says dimension mismatch, that means you've got too many X's or too many Y's. All right, now we look at our graph. Now we hit zoom 9. Now it's all centered around, and we can see that this is a linear correlation, a positive linear correlation at that. So to find the line of best fit that matches this data, so that's the line that's going to go kind of through the middle of this data, we're going to go to Stat, we're going to go right to Calc, the Calc menu, and what do you think we're going to go to? The one that says linear regression. Remember I told you regression is the math that's used to find this stuff. So we're going to use linear regression. If it's a quadratic, if your dots make a U or an N, you're going to use a quadratic regression, but we're going to talk about that more next class. Today, linear regression. Hit enter. Some of you, the numbers come up. Some of you have to come down here and hit calculate. And now here's what we've got. Notice that it says y equals ax plus b. So they're using the letter A for slope. We usually use M. Not a big deal, just a different letter. A is 1.3, blah, 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 blah. Let's round it to 1 decimal point, the tenths. B is equal to 14.5, blah, 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 blah. Let's round that to 14.5. Okay, so now we've got a line. Let's take this line and let's graph this line. Y equals 1.3x plus 14.5. Check out what happens. And that line matches the data. That's our line of best fit. Line, because it's a line of best fit. It's the line, the definition is kind of the line that's the closest to all of the points, even though they're scattered out. If you minimize the distance of all the points, that's kind of what the calculator's doing. It's finding the line that's closest to the most points. All right, so that's how we do that. What's next? So we've got a regression. Sorry, I wrote my thing on the other page. What does A represent? That's slope. That's M, slope. And we graphed it. Does it look correct? Sure does. Goes through the points. Your turn. I want you to enter this data in. Remember, we're going to want to clear our equation out, and to clear our list, we're going to go up to the name and hit clear, and then hit down. Go up to the name of the list, hit clear and hit down, and now I can start over. So I want you to enter these numbers in, follow the directions on this page, write your equation, and graph your equation, and see if everything looks good. Remember that zoom 9 will center your data. Come on back when you're done. Welcome back. I need to hurry up and do my data because I didn't pause the camera. Let's see here. Sorry for the delay. This is kind of boring for you. And there we go. So we're going to go back, stat plot, make sure that's turned on. It is. Make sure we don't have any equations. There aren't. We see a couple dots here, but I want to see them all. So I'm going to go to zoom 9, and it centers it nice. You can tell that they're not in a perfect line. That's okay. We're going to go to stat calc. For linear regression, calculate, and we get that A is 2.6 and B is 24.6. So we can say Y is equal to 2.6. Remember, it's A times X plus B, 24.6. Sorry about that. And let's quickly graph that. 2.6x plus 24.6. And look, that line goes right through the middle of all the points. Does it look correct? Yes. If it doesn't, you need to go back and check your numbers here. You maybe typed it in wrong on your calculator or wrote it down wrong, but double check because it should go right through the middle of the points. What do we have left? All right, so here I'm giving you a scatter plot, and I'm asking you which one of these lines matches. Well, you can either go through and find the coordinates for all these points and make yourself a table, right? 140 and 150, and you could do that for all these points, plug it in, find the line of best fit, or we could just kind of look. Let's see, this one has a y-intercept of negative 30. Well, this one has 30, but it has a slope of negative 2. That's no good. This one has a slope of y-intercept of 50 and a slope of 6. So if we go up 60, it should go over 6. Up 6 and over 1. Let's see, up 30 would be over 5. There we go. So up 30 and over 5. 30 over 5 is the same thing as 6 over 1. I think that's too shallow, so we need something with a little bit, well, let's see, which one is it going to be? 2x? Go up 10 and over, let's see, 2x. 2 over 1 would be 10 over 5. So if we go up 10 and over 5, what did I do here? I'm sorry, I'm messing this up. Up 30 and over 5. I went up 1 and over 5. So this is actually, this one is that line. So that's not right. Up 30 and over 5 would be here. That looks more like it. So that's the winner. This one's got a y-intercept of negative 30, which is way down here, and a negative slope, so it's definitely not that. So what you can do is graph these 4 lines and figure out which one best matches the data. Sorry for that mess up, but we are going to say that it's 6x plus 50. Go back and rewatch this example. I butchered it, but now that you know the answer and you've heard me explain it, maybe you can watch this example and get a little bit more out of it. If you have questions, please, 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 please ask me. All right, signing off. It's Mr. Morris. Have a good day.